There's also a packet for classwork and homework assignments. You don't have to print that out. You guys can treat it as a textbook type thing and then just do the worksheets on a separate sheet of paper. If you like to have the worksheets printed, that's fine as well. So entirely up to you guys. I want you guys to try to save paper if you can. So if you don't want to print it out, you don't have to. The notes, I think it's easier to have the notes printed. So just some recommendations for, I know it's like a lot of printing I'm sure you're doing for all your classes. All right, so we now move on to yesterday. I would say besides the fact that you guys set the derivative equal to 0 for critical values, there wasn't much calculus to it. It was a lot of pre-calc stuff. And so today we start to ask ourselves, well, how can we incorporate all the stuff that we learned about derivatives and help us to eventually, ultimately, sketch a curve? Okay, so the tail end of this week, we get into like putting all of it together and then sketching a curve. But for today, we talk about something called the first derivative test. So because it's called the first derivative test, then you guys know that you'll be somehow using the first derivative to help you determine characteristics of the test, or sorry, of the function. So quick review, when we say a function is positive, and this is just simply not the derivative, but the function is positive, we would say that this is true when the y values are above. If I'm looking at the graph, I can tell that the y values are positive when the graph is above the x-axis. Okay, and that's where all your y values are greater than 0. Okay, we can tell a function is negative when its y values are below the x-axis. So this is just looking not at calculus yet, but just function values, right? How do I know if it's positive? How do I know if it's negative? Okay, so on just to practice this, you guys, can I have you write the interval for example number 1 of when f of x is, let's do two things. Let's do f of x is greater than 0. Can you guys write the interval for that? And then f of x is less than 0. And can you guys type into the chat what you get for the intervals when it's greater than 0? And we can use interval notation from here with a union notation in between. So u, if there's more than one value. So go ahead and type into the chat, when is f of x greater than 0? Perfect. And then if we can just, if I can have you guys type into it from here on out, just private chat, just to give other people a chance to answer, because I noticed that sometimes when they see the answer too soon, we tend not to participate because someone else has gotten it already. So just private chat the answer from here on out. Okay, so many of you guys put -1 to 1. That's good. We don't include -1 and 1 because those are when f of x is equal to 0. So now can you guys go ahead and private chat that f of x is less than 0 for me? Okay, from the ones that I've seen so far looks good. Okay, and then we will move on quickly to, so many of you guys put -infinity to -1 union 1 to infinity. Now can I have you guys try to describe the second function? Okay, try to describe the intervals of increase or decrease on the second function. No, sorry, not intervals increasing or decreasing, but when is it positive or negative? And I apologize with the confusion. It's not intervals of increase and decrease, but just when is it positive or negative? Oh, thank you, Brandon. Good. Okay, keep typing. I'm getting some different answers this time. Okay, so my question back to you guys is, yes or no, do we include 2 in the interval? Yes or no, do we include 2 on the interval for when f of x is greater than 0? Okay, good. So some of you guys have corrected that. So f of x is greater than 0 only on the interval from -infinity to 2. Good. Union, we don't include 2 because at 2, y is equal to 0. So those are just kind of the subtle differences in when we're summarizing our answers for that. Okay, so now we're going to talk about, and I'm going to use the graphs that I see above here as an example, but we've talked about it before, you guys. So if I'm talking about the derivative, let's say these are my, and I'm referring to this parabola now. These are my original functions, and I'm talking about derivatives and what the derivative represents. The derivative is the slope of the tangent line at a single point. So here we see that the slope of this line that I'm tracing, this, let's say the tangent line, sorry, horrible tangent line, is positive. And then it reaches a point where the slope is 0. And then it reaches a point where the slope is negative. Okay, so it transitions from when we've noticed that when the derivative is positive, the function is increasing. When the derivative is equal to 0, there's something that occurs here. This is a max. And then when the derivative is negative, we see that the function is decreasing. Okay, so same thing is true over on this side. And let's incorporate what we did yesterday. When we found our critical values, okay, we remember I kept emphasizing we don't know for sure if it's going to be a max or min. It's a possible max or min. But if we can describe that there to the left that the function is decreasing, then increasing, or that the derivative is negative, then positive, that there's that change in sign, we can then isolate and conclude that this is a minimum versus it goes from derivative being positive to derivative being negative, that's a max. Basically, that's your first derivative test. Okay, so down below here, we're going to incorporate this into an example problem. But yesterday, what you guys did was you found critical values. You found x values where f prime of x is 0 or undefined. So these are what we did last night. Find the critical values. Then what we're going to do is create something called a sign chart. Okay, so sometimes you guys will hear me say, create a sign chart. That's step 2. You're going to plot those x values you guys found in step 1 and break up the number line into open intervals. And then we're going to pick test values. A test value is just a number within that open interval that we're going to use to determine if f prime is positive or negative. So very similar to when we were determining if a function was moving right or left. And then after that, our conclusion is f prime of x is positive, therefore f of x is increasing, or the opposite, f prime of x is negative, and f of x is decreasing. So first, before we get to determining whether or not it's a max or a min, we're just going to talk about increasing and decreasing with the sign chart. So below there, example 2, what we're going to do is on step 1, can you guys find your critical values for that? So go ahead and find f prime of x and type into the chat, what are your critical values? Okay, good. Many of you guys typed in 1. We took the derivative, we set it equal to 0, we factored out the 2, or we just solved it and we got x equals 1. Okay, so that is nothing new. Now what you guys are going to do is create a number line. The number line represents negative infinity to positive infinity. You put the critical value that you guys just found on the number line, and then you pick a test point. So this is going to be me picking a test point. And I don't always write out the test point, but let's say you guys wanted to write out what value you're testing. So from negative infinity to 1, I can pick an easy test value and pick 0 here. After 1, the first one whole number I can think of is x equals 2. Those are the values that you would then plug into, I would recommend plugging it into here, into your factored derivative, and then determine if it's increasing or decreasing. So above x equals 0, what I'm going to do is plug 0 into that, and I get a negative value. So this is actually, I'll write it out because it's the first time. You're plugging 0 into x and determining that this is less than 0. So therefore, what I'd like you guys to do below that is draw what that actually represents. Okay, so if the derivative is less than 0, then my function is decreasing. So go ahead and draw a line segment that represents like a negative slope, a decreasing. Okay, x equals 2. If I plug 2 in, I get something that's positive. So then positive slope would be a line segment that's increasing. So I can see that it kind of gives me an idea of where the first derivative test is going to lead eventually. I can see that if a function goes from a negative derivative to 0 to then positive, that this is eventually going to lead me to conclude there must be a minimum here. Okay, and that ultimately is your first derivative test. So this one just simply asked what the intervals of increase and decrease are. So go ahead and put INC, increasing. We would say from negative infinity, because it's not a closed interval, to the critical value of 1 is not true. Increasing would be from 1 to infinity, and then decreasing would be from negative infinity to positive 1. Questions in the chat, private chat, any questions on what we just did there? Okay, so what we do a lot in AP Calc is switch back and forth between, as you guys know, looking at position function, velocity function, looking at the graph of the original function, looking at the graph of the derivative function. So below here, go ahead and highlight or underline the fact that this is the graph of not the original function, but the derivative. And then now they're asking us to find f of x where it's increasing and decreasing. So what I suggest you guys do is first mark that this is the derivative graph. And then below that, can you get, that's a horrible line, but draw a line below that. Okay, this is going to be like the equivalent of the line that the sign chart that you guys created above. And what I want you guys to do is now picture right here and right here. Do you notice that f prime of x is above the x-axis? Therefore, it's positive on those values. Whereas below here, we know that f prime of x is negative. So what I do is I go to where it's equal to 0, -1 and 3. Mark that off on the on your sign chart. Okay, so that's where f prime of x is equal to 0. That's where my critical values are. And now below that, you guys can say, okay, well, if it's the yellow highlighting is above the x-axis, f prime of x is positive, that means my function should be increasing at that at those highlighted areas, so on those open intervals. Okay, so between negative infinity and -1, f prime of x is above the x-axis, therefore my function should be increasing. And then the blue highlighted part is below the x-axis, therefore I know f prime of x is less than 0. So I'll just write this out. F prime of x is less than 0 here. F prime of x is greater than 0. And so I know that with that, I know that the function the original function must be decreasing. You guys don't have to draw it out, but I already have a sense of what this graph is going to look like. And it makes sense because the graph that I'm tracing right here is a cubic function. Okay, the derivative of a cubic function is x squared. Okay, so kind of getting a feel of what the function is going to look like. Any questions on that? Oh, and it does ask for when it's increasing and decreasing. So let's summarize. So increasing from negative infinity to -1 and 3 to infinity, whereas it's decreasing from -1 to +3. All right, let's put that all together now and talk about the ever important first derivative test. Okay, so we do the same steps that we do above there. Okay, you find all of your critical values. Again, that's not only where f prime of x is equal to 0, but where it's undefined. You plot the critical points, you create that sign chart. So this is sign chart part. Okay, determine the signs of each interval. So all steps 1 through 3 is what we just did on the previous problems. Okay, so on 4, if we notice that f prime of x, and I'll point out to the above, if f prime of x changes from positive to negative, so from positive to negative, then there is a maximum that occurs. Okay, so versus if f prime of x changes from negative to positive, then it goes from decreasing, the original function goes from decreasing to increasing, there's a min there. Okay, so can you guys write AP note here? I meant to type it out, but I forgot to. AP note, a sign chart is never sufficient. Okay, so on your free responses, you must explain in terms of derivatives. Okay, meaning that you can't just say, look at the sign chart, that's my answer. You have to explain the process that we just did in steps 1 through 5, and I'll go through, it's not very intense to do that, but I just want you guys to know just a sentence to explain, and I'm always gonna emphasize this to you guys, you're in calculus, so you want to describe things using calculus. So I'll give you an example of describing it using pre-calc, and then describing using calculus. So let's first find example 4. Find the critical points of the function and determine if it's a local max, local min, or neither. Okay, so I'm gonna stay quiet for a moment. Can you guys go as far as you can? Find all your critical values. See if you guys can come up with a sign chart. And if you need to look up, I will work out the problems quietly. So just as to give you guys a chance to try to see if you have questions as you are working out that problem. If you guys look up real quick, I've gotten to the part where I found the critical values -3, 3. I created the number line, and then above that I put a test point that was within that open interval. I just want to show you guys the most efficient way of doing this. I would take -4, and I would keep in mind that 3 is positive, it's not going to change anything. But if I plug -4 into here, I don't necessarily have to know the numbers. I know that -4 minus 3 is a negative number. And then that -4 plus 3 is a negative number. So negative times negative. So above there, I put negative times negative, which is positive. Then I just draw my increasing segments like that. Okay, go ahead and try that for the rest. And feel free, you guys type into the private chat if you're stuck on a spot, a step. And yeah, feel free to see if you guys want to type into the chat what your conclusion is about -3 and about 3. Okay, very nice. The answers coming through. Just to clarify something, when you someone had this question, they asked for the notes above if it goes from positive to negative. Positive, prime of x being positive means that it goes from increasing to decreasing. So if I trace something that goes from increasing to decreasing, that tells me that that's a max. Okay, so that's correct. So it goes from f prime of x goes from positive to negative means that this is a max. Hopefully that makes sense to the person who asked that. Okay, and very nice for those of you guys explaining it very thoroughly. So just a few things, since it just says to determine if it is a local max or a local min, I don't have to worry about like specifics like what the actual value is. So just to walk you guys through, I'm going to write down the answer to it, and then I'll talk to you guys about what if the question had asked something differently. So I would say at x equals -3. Okay, at x equals -3, there is a local max because f prime of x is equal to 0 and changes from positive to negative. You guys, this is sufficient. You don't have to, I see people eventually writing like paragraph long explanations. You have to mention that you address the critical value part of it. Okay, f prime of x is equal to 0 or undefined. And then you have to make sure you mention the sign change from positive to negative to address the fact that it's a max. Okay, so that you don't have to say, oh, and don't say by first derivative test. They don't like that either. So you want to actually describe the first derivative test. So that's a sufficient answer. Try to go ahead and write the explanation for x equals 3. Okay, here comes the nitpicky parts. Okay, so if you were to get this on a free response for your test, and you guys say it is, let me describe this. There is a max at x equals -3 because f prime of x changes from increasing to decreasing. That is incorrect. Okay, one, f prime of x, you guys want to describe in terms of signs. It changes from positive to negative. F prime of x increasing and decreasing, now you're talking about the derivative of f prime. So again, when you're describing the first derivative test, talk about the sign change from positive to negative, negative to positive. Also, if you are talking about, okay, good. I thought there was a question. If you're also talking about this in terms of precalc, so think if I didn't know derivatives, how would you identify or describe a max? You might say, oh, the function is increasing, f of x is increasing, then it decreases. So therefore there's a max. Okay, in those terms and in that explanation, I didn't use a derivative at all. I didn't say that the derivative changed. I just said the function changes from increasing to decreasing. A pre-calc honors student can provide that explanation. So that's not going to be sufficient for the AP Calc test, right? We're going to describe it in terms of calculus, which is that we want to describe it in terms of derivatives. Okay, so always keep that in mind. Am I using calculus? Am I talking about the derivative? Am I just talking about the original function? Okay, so on 5, why don't you guys try to find the derivative and see if you guys can find the critical values first for that. And I will tell you guys there's 2 critical values. Whenever you guys have 2 fractions, always in your analysis, You guys want to make sure you rewrite it as one fraction. Okay, good for the person who had already gotten it. Okay, good for identifying the critical values. And also, I'll tell you guys some confusion with this also is sometimes we plug the test values back into the original function. For this common mistake, I'll just say you guys are applying the first derivative test. So make sure when you're plugging in your test values that you're plugging it into your first derivative. And your sign chart can also be like when you plug 1/2 into the top, you know that it's positive. And then when you plug 1/2 into and I'm talking about this. If I plug 1/2 into the top, I get something that's positive. And then when I plug in 1/2 at the bottom, I also get something that's positive. So a positive divided by a positive is positive. So therefore that's increasing. And then do the same thing for 2. And go ahead and write out your explanation. Okay, I love the explanations coming in so far. That's complete full credit for those of you guys who typed it so far. So it's going to be important that we work on just making sure we have all the stuff that they hit upon for grading. But yeah, the ones I've seen so far are good. And we are going to wrap up notes soon, and then I'm going to have you guys practice in some breakout rooms, some of this stuff. So any questions on that before I move on? Here's the correct explanation. Okay, always use derivatives in your explanation. All right, so now going down to, I'm going to skip over that blurb, and we're going to look at the last example here. Okay, so on this last example, here's what I want you guys to practice doing, and maybe we'll do one together. Okay, so highlight or underline and this is going to be important. Whenever you guys read a free response question, you're going to highlight that. If you see that the graph right there is not f of x, and 90% of the times you're not going to be given I would almost want to say 100% of the times, on the AP test, you aren't given the graph of the original function. It's usually of the derivative that they then ask you guys to analyze information on. So here they want you to find the critical points of f of x. So actually, let's go ahead and label a couple things you're going to find. Okay, so let's find critical points first. Can you guys on that graph type into the private chat, what are your critical points? If that's the graph of the derivative, what are your critical points? Okay, good. As you guys are, so I see the numbers coming in. Those look good. Okay, if you still don't have these, can you guys also draw your sign chart? Okay, so I draw a sign chart and I mark off where those critical points are. -1 and 3 are my x equals -1 and x equals 3 are my critical points. Okay, and then if you guys now can determine and create the sign chart on here, like to the left of -1, I can see that my graph is above the x-axis. So f prime of x is positive, right? And then below that, it's negative. But one other thing I'm going to mention, this just says find the critical points and if it's a max or a min. So we're just saying general information where it occurs. So when what I want to emphasize is if they actually ask you guys for min and max values, you would then plug it back into the original function. Here we don't have the original function. However, in the previous examples, had they asked for what is the maximum value or minimum value, that's when you guys would, a min or max value is the y value, right? So you would plug it back into your original function if they asked you for what the actual value is. So here they just want to know, is it a max or min at that point? So hopefully you guys wrote x equals 3 is the minimum, and then x equals -1 is the max. All right, so on graph B, last example here, can you guys identify the critical points for me? Identify the critical points for me. Good so far. Very nice. Everyone who's typed it in is correct so far. Okay, highlight if it helps you guys where it's above the x-axis. Okay, can you guys type in the chat, where does your local min occur? Where does your min occur? Remember, you guys, when you're looking for a min, you're looking for a change in the signs of the derivative as well. And also a question came through when we're asked to find, that's a good question because I see that confusion sometimes. When we are asked for a max or a min value, we plug back into the original function. What is a min or max value? It's the highest y value or the lowest y value. So those are the original function y values, not the derivative function. Good question. Okay, so I'm going to identify now what the local mins are. We have not discussed what this is. Okay, at x equals -2, we notice that it's a critical point. Think back to yesterday, you guys. I kept writing in your notes like sometimes those critical values are not maxes or mins. Okay, so in order for it to be a max or min, there needs to be a sign change. This went from positive increasing to increasing. Okay, here is an example eventually of what that might look like. The x cubed function goes from increasing to increasing, but the derivative of x cubed at 0 is 0. So that point is called something called an inflection point. It's not a max or a min. We're going to talk about that one tomorrow, but that is not, so this is x equals -2 because there was no sign change. It just went from increasing to increasing. Even though this was 0, we would not classify this as a max or min. So then the only possible min is at 3. Okay, so if you didn't have that, make sure you guys correct that. It's only at x equals 3. And then that leaves our max to be 1. And physically, hopefully you guys see it as this, but if you look at the graph itself, this is like increasing, increasing to decreasing, then decreasing to increasing. So here you guys see that there is a max that occurs at 1 and then a min that occurs at 3. Okay, whereas it doesn't happen at -2.